Good evening, folks. My name is Sitaram Param. I'm one of the senior director in the Cloud Management BU's engineering team. My colleague here, Dharma Srinivasan, she's a senior manager working on the same team. Today's session is about how we implemented Self Healing DevOps Pipeline to increase the success rate of the pipeline using vRealize products. Before we go into the deep dive into the session, I also want to share our experience about the journey that we took, the DevOps journey that we took, just briefly. And then we'll talk about vRops pipeline. vRops is one of the big products that we have in our portfolio. We will take that as a case study. We'll go into deep on how we implemented that pipeline, and also we will talk about why we had to implement this self-healing solution, and then Dharma will come and talk about how we use vRealize products to implement that solution, and we will also go through the runbook of how you can go back and implement this solution using vRealize in your company. So, the challenges that we have in the cloud computing era is almost similar, right? So the competition is fierce, and the technology stack is changing so fast, and we have to always innovate. We cannot take break. To do this, we have to be faster and we have to be more agile. While doing this, we always have to maintain the quality and security. We cannot, and also maintain the cost. We cannot compromise on any of those things. We cannot say we improved the productivity 10x, but we needed to spend 10x more. That's not going to fly. So with these challenges, look at our challenges. Our business unit is, again, we are actually one of the big business unit in our company, and we have 6 on-prem products and 3 big cross-cloud services that we announced in this VMware. So we had the same challenges. Our releases used to take 6 to 12 months. And when our developer check in the code, it used to take 2 to 4 weeks for them to get any feedback. Too many manual steps involved before we certify a build. If somebody wants, hey, can we try this vRops build for some purpose in the in-flight release, you cannot just give it to them, right? It takes 2 to 4 weeks. And the automation was not that good. The test automation percentage was very low. And we were not running any scale performance testing in the pipeline. We were always running outside. After the certified build, then our scale performance team goes and takes that build and run through some tests for a couple of weeks, and then finally it goes to customers as a beta and all that. So we were traditionally following that waterfall approach, planning, development, testing, and all that. So what did we do? Again, this session is not about going into details, just a high level. What we did is, we actually combined all the engineering teams. We had R&D, QE, separate teams. We put all of them together. In some cases, we put all of them under one engineering leader. In some cases, we virtually formed the team. So basically, we removed the silos. And then there are 2 teams that we formed, R&D team and the extended R&D team. We call it Engineering Services Organization. So the R&D team is responsible for developing feature and writing tests for that feature. So our developers write the functional tests. And the other team, the extended R&D team, they do the CI/CD pipelines. They implement the pipelines, they maintain the pipelines, they also do the system level validation. We also started looking at some KPIs, code coverage, test automation. So another important thing is mean time to delivery. This is how much time it takes from the check-in to the certified build for the on-prem product, or how much time it takes from check-in to production for the SaaS services. This is a very important metric that we track. So, and also we had to initially slow down the feature development to implement some of these pipelines, tooling, and test automation and all that. With these changes, look at where we are right now. We have 6 on-prem products. vRealize Operations, Automation, vRealize Business, Log Insight, Network Insight, with all that. And then we also have 29 SaaS services. Yesterday, we announced 3 cross-cloud services: Cost Insight, Discovery, and Network Insight. But underneath, we have 29 microservices. For this SaaS services and on-prem products, we have now 46 fully automated pipelines we implemented using vRealize products. So now, for on-prem product, from the check-in to the recommended bill, it takes less than 24 hours, fully automated. And for the SaaS services, it takes less than 2 hours from check-in to the production. In this case, it goes all the way to production. Every check-in goes to production. And we almost deploy 10,000 VMs to run these tests for all these products. VMs, in some cases, containers. So if you really look at it, it's not a small shop that we are talking about. 46 pipelines and 10,000 VMs that we deploy. So now let's look at one of the pipeline, vRops products pipeline. vRops is a big product. We have developers all over the world, and when they check in, we cannot serialize that check-in. We cannot say developer is checking in the US time zone, you cannot check it in the Europe time zone, we cannot do that. So when a developer check in to our pre-check-in system, in parallel, when 10 developers check in, we actually invoke 10 different instances of vRops product, run the test, and if the tests pass, we automatically push it to source control system. Once the check-in is in the source control system, we have this, we call this basic acceptance test. So our pipeline, we implemented using CodeStream. It looks for the check-in in the source control system, and when there is a check-in, it invokes the basic acceptance test. And then if those tests pass, we run all our automated tests. For vRealize Operations product, we have 10,000 automated functional tests, 50 enterprise readiness tests. Enterprise readiness is backup restore, disaster recovery, those kind of tests. End-to-end test is persona-based use cases testing, and scale performance test is API, UI response time, some feature level stress testing. All these tests are running in the pipeline, all of them. All of them need to pass for us to get to this recommended bill. So if you really look at it, from the check-in, the time that we get the certified recommended bill, it should be taking only 15 hours. But it was not. Why? It used to take actually 40 hours, more than 40 hours to get the recommended bill. Why? Because the pipeline was failing. The reason it was failing, when we looked at those failures, more than 50% of the failures were due to test infrastructure issues and test stability issues. This is what happened. When we have these many failures, infrastructure, test stability issues, the developers are going to be burned out. There is a term in the industry called DevOps burnout, right? When that happens, your developers are going to leave because they can't control, you can't maintain these kind of pipelines. So we have to be very, very careful. When we looked at it, we thought that there's something needed to be done. So what we did is, let's go through this. So this is the pipeline. There's one more thing that we don't show here. From our pipeline. Our pipeline is implemented using the product called vRealize CodeStream. How many of you are aware of vRealize CodeStream? Okay, 2, 3 people. So this is the pipeline orchestration tool, and this is not to compete with any open source tools like Jenkins. You can still have your jobs in Jenkins. This is just an orchestration tool. You can actually put together the pipeline, and you can actually, if let's say we talked about the basic acceptance test. When you want to run that, you can actually call the Jenkins job. So it is not competing with Jenkins. It's actually on top of Jenkins. So it's an orchestration engine. So in this engine, we also call VRA pipelines. Our test beds are, we have blueprints in the VRA, vRealize automation product. So this CodeStream product is tightly integrated with VRA. In fact, it's the same installation. So this CodeStream can call the VRA to deploy the test beds. And then we collect all the logs and metrics to VROps and log inside. Think about this. When you deploy, as I said, we are deploying 10,000 VMs. We have to manage that environment. There is a huge infrastructure behind it. We collect metrics and logs from that infrastructure. And we are deploying VROps product. And that product, you have to collect logs from there. If there is a problem in that product, we have to know. So we collect almost all the logs and metrics and feed into VROps and vRealize. And VROps and vRealize, we go and create the rules. So if there is a problem, we can actually, these products can send the alert. Those alerts are getting into our self-healing engine. This is the custom code that we wrote on top of some of the open source webhook that Dharma will talk about. So this self-healing engine takes these two alerts and then decide, oh, the test failed because of this reason. And then it actually go and invoke the VRO workflow, which will go and remediate that problem. So that way, developers doesn't need to do anything. When the pipeline fails, developer doesn't need to do anything. So it will go and heal that problem. With this solution, our mean time to delivery was 40 hours. We now reduced to less than 24 hours. So every 24 hours, we get the recommended build for our on-prem products because of this solution. So now I'll invite Dharma to come and talk about how we implemented this solution using vRealize products.
Hi, everyone. So what you see until here is a 1,000-foot overview of how we have improved the quality of the builds, right? And what we want to see is how can we now improve the quality, not just the quality, but the frequency of successful builds? Because you don't want just one good quality build coming in once in 48 hours. You want a good quality build coming in for almost every check-in that goes in. And like Sitaram was mentioning, these failures are not just happening because of product issues, right? And if those are true, then that's fine, because you want your developers to go in, improve the quality of their code itself. But what about the issues that happen, the failures that happen because of test failures and because of infrastructure issues? You certainly don't want your developers sitting there and figuring out what is the root cause of the problem. So what we have done is put together a solution, a toolkit of sorts, using all of these vRealize products that we hope that you already have in your lab, right? And if you don't, then we'd highly recommend that you do. And then you will see that you can leverage the power of the core value of each of these products to put the solution together, right? And so we'll start with the case study that Sitaram already started on, with vRealize Operations being our product, one of our products that needs a pipeline. And how did we put this self-healing solution into that pipeline and make more successful check-ins come out of the vRealize product? So what you're seeing here is a pipeline execution dashboard. So this is CodeStream. What CodeStream gives you is orchestration of your entire pipeline and then a visualization of the same thing. What you're seeing here is we will briefly focus on the orchestration a little bit, then we will move on to the visualization. When I say orchestration, again, I'm sure everybody here knows about the various different types of tests go in, but little refresher here, right? So what this little instance is showing you is, for that particular check-in that went in, there were these different types of test suites that ran, and First, you had a pre-check-in that went in. The pre-check-in test passed, and it went in successfully through that gate, the gating rule. And then it went and ran the BAT test, the build acceptance, basic acceptance test. If those passed, it then now goes in and runs a regression test. And regression tests are flexible, right? They are more, you can run different types of tests in parallel. And you could run your scale tests, your end-to-end tests, everything in this one bucket. And once you're done, finally you have your recommended build. And so in this one picture for that particular check-in, you see every stage that it went in and how it finally became a recommended build, right? Now, you've seen this just for this one check-in. What about if you wanted a more higher level overview, a bird's eye view of across check-ins? Because you're not just a developer, you are, let's say, a different persona, a DevOps manager or someone who wants to know across the board in my product, what is the quality of my check-ins looking like, right? And this one is more for that particular developer who says, I want to know what happened to my check-in. So let's go to the next one. This is your high-level bird's eye view dashboard. So this is pretty powerful. If you look at this, what we are showing you is across the check-ins, there's this list, chronological order, and for each check-in, it gives you every metric that you're interested in terms of who was the developer who tried or attempted that check-in, what happened to it from the perspective of each type of test that went in, and which stage did it finally pass or fail. And you will notice one thing here is you'll see these green dots and blue dots. What the green dot represents is each of these test suites passed, which means that it went through the gating engine and it was able to go to the next level. And you'll see a last recommended green dot only if everything was green across the board. And there are these reds that you see all over the place. That basically represents a couple of things, right? You could see multiple greens and a red within that one regression suite. That's just because it's running in parallel. But it is not going to let you recommend the build anyways, because at least one of those test suites is red. But if the same red or failure was to happen before in a non-parallel or a sequential test suite, it is not going to let you go to the next thing at all. So if you notice, you will see like in the builder or in the tester phase, in the pre-check-in, everything else is gray because there's no point running a test after that. So it allows you to obviously control and gate the tests at the right place. Find the issues early, because all of us want to find the issues as early, fail as quickly as possible, and come out and go fix the problem and come back here, right? So this is a little something about the code stream dashboard itself. Now, we'll go on to the next thing. What you saw in that diagram that Sitaram was showing was how do we first deploy the test bed before it even goes and runs the tests. So what we have done is leveraged VRA for the purpose of deploying the test bed. So in this case, what you're looking at is the service catalog of vRealize automation, and you're looking at a set of blueprints that will, when initiated, deploy a VROps instance. And why do we have this here? So when we want in the pipeline to run a test against a VROps instance, we need a VROps instance to be deployed automatically, obviously. So what we've done is, and VROps instance, and we'll look at it in the next screen, is not a simple instance that you can just build very easily. So VRA is a perfect recipe for that, because you can build a predefined, well-configured topology into a blueprint and set up various different blueprints here, and then you can either request it by, your DevOps engineer could just go request it, or you can use your APIs and your pipeline could request these and set up the instance of the blueprint. So coming to the next screen, now we are going a little bit deeper into how that actual instance of a blueprint looks. So anybody here with an experience with VRA? Oh, okay, that's good. So for the people who have not yet had experience with it, I will just go into a brief overview. What you're looking at here is one of the VROps blueprints, and what a VRA blueprint gives you is the capability of creating a topology which you can visualize. You can set up your software components, your node topology, in fact, even your dependency between the various different nodes in a very easy visual pattern here. So essentially, when you look at all of these dotted lines and arrows, what it is representing is, hey, there is a bunch of software components that need to be installed, and they are residing in various different nodes here and have a dependency of some sort. Maybe one needs to read an IP from the other, so don't deploy this before the other one. So this dependency arrow allows you to set up that such that when this actually gets deployed, it will honor all that. And so you will not have any race conditions, and your finally deployed instance will run, perfectly configured. And in this case, I want to go a little bit more and explain. So what you're seeing here is a multi-node deployment of the data node of that VROps instance, and a single node deployment of your master node, and a test client. Essentially, what else do you need for a test bed, right? You need a test client, and you need the actual product installed. And within each of these nodes, you see the software components, and these are essentially the Linux scripts that we execute to configure the various different things in our instances. Any questions before I move on to? People seem to be recognizing most of these things. So, okay, so we've seen how we have leveraged so far CodeStream and vRealize automation in this toolkit that we are developing. The next thing that we are also leveraging is the power of Log Insight. Anybody here that has used Log Insight? Okay. All right. So for the rest of you who have not, Log Insight is a very powerful data house for collecting all of your logs from your test beds, from your deployment instances, and essentially at the end of the day, your troubleshooting person, like let's say something fails, your systems engineer, anybody who wants to say what exactly happened, why did something fail, they can just go query very easily from this already pre-collected set of data and set up alerts based on all these queries that they have already configured. And life is just easy. If the same problems happen again, you already have an alert set up for it. And if you haven't set up something, it's very easy for you to configure the same thing, right? So what we did is use this power in our solution. And what you're looking at here is one of the alerts that we've set up. This alert is set up based on an exception that is frequently occurring from our end-to-end tests. So we know from our experience in the past that this happens, and this is how you can query for it. And if it does, this alert is going to bring up a notification that, hey, particular exception has happened for that suite. Correlation happens, right? So this is an example of how that alert is set up. And what you'll see next here is the webhook that Sitaram was referring to. What we did here was combine the power of a little small open source toolkit along with our product, because what we are attempting to get out of this webhook is get the alert triggered from our product and then have something listen for this alert. Listen for this, send this information to our custom code. And I will come to that in a little bit about why we need that custom code. We'll actually go a lot more deeper into that. But once this webhook gets this information, passes that along to the custom code, the business logic in that custom code is going to do the next thing that is required such that the right VRO workflow gets triggered. And this entire discussion is moot if we don't have a remediation in place. What are we self-healing if we don't have remediation? So those VRO workflows are giving us that remediation, right? And this webhook is going to be that flexible engine through which you can get that whole notification sent all the way over and get that triggered. So we've looked at Log Insight. The next thing that we also leverage in our self-healing solution is vRealize operations. So vRealize operations also has alerts, just as you saw with login site. And these are the list of alerts that we have set up in our instance for our VROps pipeline. And one of these, as you can see, is the data store running out of disk space. And you will see a few more screenshots over time in this presentation that takes that as a case study and shows you what we do with it. Right? So that's what I was referring to, and we will just, yeah. So what we are doing here is something very similar to what we did with login site. Again, the webhook comes into the picture here, right? So we've set up or configured that alert to send to that endpoint, the webhook endpoint. And a little something that I want to note here as part of an implementation detail is there is something called a REST notification plugin that comes out of box with VROps. All you need to do is go to your admin interface and create an instance of this plugin, and it's all set for you. And if you do that, you will be able to then use that plugin to create this type of an alert, which can send that alert notification over to the webhook. And yeah, this is a little bit of a detail there. Now that you've seen how each of our vRealize products came together, we are now going to focus a little bit on that custom code that we've written, just to show you how it all fits in, how it ties together, right? And it's kind of like a refresher to all the various different slides we have gone through so far. So you'll see that there is an alert coming from VROps, an alert coming from login site, and it goes through webhook, as in it gets picked up by it and gets sent over to our self-healing rules engine custom code. And from there, the remedial action takes place. So coming back, why do we even need this webhook in place? Because we want a business logic written in this rule engine to correlate the alert that comes from login site and the alert that comes from VROps. Why do you need the correlation? Your VROps alert might be saying, we are running out of disk space. Your login site alert might be saying something very similar, of course in a different language, because based on what logs it is looking at from your test. So, and multiple other things might be coming up from that test log as well. So what you can do here in your custom code is correlate both of these, because the IDs that are coming from both are different. So if you have this custom code, it knows to connect the two, have the next action be determined based on this connection and correlation. And the next action, what you see here, is that action repository. What that action repository is nothing but a list of the VRO workflows that we have predefined. And why have we predefined them? Because they are the frequently occurring issues in the past, and we know what the remedial action should be. For instance, that data store issue that we were talking about. So we've written a workflow in our VRO earlier, and that is already, this action repository is aware of that VRO workflow, so that the next time that problem happens, all it needs to do is go trigger that VRO workflow. There's nothing more to be done there, right? So that is the reason that you have this little custom code. But that said, I want to mention one thing. It is not imperative that you have to use custom code here. Our goal here is to make things as simple for you and as efficient for you as possible, right? So if, let's say, in your environment, in your lab, you frequently ran into issues that you know don't need correlation. It's just infrastructure issues. Your VROps alerts will just perfectly do well for you. You could, in that case, look at optionally not having a webhook there, not having a custom code there, have the webhooks directly trigger a VRO workflow itself. So that basically cuts down a little bit of your complexity there. But again, it's not complex as much as it's just another piece of code sitting there. It's very simple, small set of things to do, small business logic sitting there. And another thing that, while we are on this topic of flexibility, is we are trying to make the best use of each product such that you can get the power of each of them. But it could be possible that you want to iteratively start using each of these products in your lab. So are we saying that you cannot be up and running until you had everything configured? Not so at all. For instance, what you could think of doing is, let's say that you are starting with very simple blueprints that you want to deploy. You may not need to start off with VRA at that time. You could start off with a simple script and set up the rest of your entire engine in place. And then as you need more complexity in your blueprint and in your deployment, at that point, go back, leverage VRA, set up your blueprints there, because it gives you a highly versatile platform to create very complex blueprints, right? So it is totally up that you can fit in any part of this puzzle at a point that you would like to. So this is the big picture, how you fit it in what sequence you fit it in. We will help you decide, and of course, we'll help you create that pattern as well. So next. So we saw a little bit on where do we actually take the remedial action. So this is an example of one of those remedial actions. What we have done here is that action got triggered from the custom code in VRO. This is just a VRO workflow that you must be used to if you have used VRO. Anybody here familiar with VRO? Okay, I see a few hands, good. And so you must be used to the workflow. And at the end of it, this is the crux of the self-healing engine. We've been talking about remediation and remediation. What is this remediation? What is it actually doing? At the end of this, it is going and rerunning that test case. Because remember, on the dashboard, we saw those greens and reds. So what do we mean by self-healing? What we are saying is, you don't need to babysit your pipeline. Something fails, it goes into this engine, looks at why it failed automatically, goes and triggers a remedial action. And the remedial action here is to say, I'm going to fix that infrastructure problem that happened, and then I'm going to rerun the test. And when that happens, if that did actually get fixed, that same test goes back, runs, becomes green, and your recommendation just happens. So the main takeaway is that little thing. If you need to determine what kind of action you want to take with your test suite. There may be cases when you want to disable a particular test suite because you believe that from all of the remedial actions you have taken, you understand that that wasn't a product issue, it was maybe just a test issue, and you don't want to penalize the recommendation of your build because of a test flakiness. So your actions here at the end of that remedy could be anything based on what kind of problem that was, but this is the crux of it all. So, yeah.
There could be a myriad of infrastructure problems when you get big infrastructure.
Of course.
So how many VRO workflows do you guys have to write to remediate so many possibilities?
So you saw a small list of alerts that we have in place there, but we are not going to get you the entire list and the entire count. But let's just say in the tens. But it depends on what kind of issues you will run into in your lab. Sorry, any other questions? There is a little other segment we want to go into. Before that, I want to just make sure that it's clear.
Usually the symptoms could be many, but the solution for those problems could be a change the VM configuration or restart something, right? It's not going to be that many. But symptoms could be many, right?
So basically, what it's doing is, to begin with, we are making the system learn by saying, hey, these are the frequently known issues, and we already know what to do with it. But over time, what the system also will do, again, that's the custom code, not the rest of the product, is to start self-learning and saying, okay, now this is a new problem. I'm going to put in a draft for what could possibly happen with it. But then somebody goes and approves and says, yes, this will be the remedy that we will take, right? So that is the next phase in this entire picture. So we've seen how to leverage all of the products from the vRealize suite and create this entire solution. What we want to see next is how can we make this easy for you to set up in your lab? And of course, if you choose to do this, we would love to help you make this even simpler if you find that any step is complex for you. So So what you see here is, again, just a refresher of the various different things we have seen as slides so far. So you, first of all, have to deploy your vRealize suite products, and like we talked about, the products that most are important in your use case, and then go and build the rest of them as well. And then orchestrate that pipeline in CodeStream, and we looked at that a little bit. And once you have the pipeline orchestrated, in which you will know what tests will be running, what kind of blueprints you will need, all of those get determined at that stage. Once you determine that, next you will know, okay, I'm going to go to vRealize automation and create the blueprints for that, right? So the next step will be to create the blueprint for the test bed. So let's say that that is done. The very next thing that you will do is configure your vRealize login site and configure it such that it goes and receives all of the logs from these test environments that have been deployed. And the next thing, configure your vRops such that it receives the metrics from these test environments. And at this point, you've configured both of them. What are you going to do next? You have the information in hand, but now you want to be alerted. You want to be notified. So then you will go and create the alerts that you have identified and the queries corresponding to those alerts for both vRealize and vRops. With that in place, the very next thing we talked about a lot here is how do you set up these alerts to be configured to go through that webhook engine. And once that happens, of course, now you need the VRO workflows. You have everything else in place. And once something has to be triggered, you need the actual workflows. So configure the VRO workflows as well at this point. And once you have the workflows in place, now you're coming to your custom code. Now you're telling your custom code, I have everything in place. I have the logs, I have the metrics, I have my remedial workflows in place. I just need to fit the pieces in together at this point. So you will tell the custom code, these are the remedial workflows to take or trigger. Basically, these are the workflows to trigger. So hopefully this is simple, but like I said, as you try this out in your labs, we would love feedback. We would love to make this simpler for you. And of course, this is our bread and butter. We do this in our lab. We use each of these self-healing pipelines, and we are trying to make this solution better every day. So this is a changing picture. Tomorrow we might have a much simpler solution for you here. So any questions?
So how much engineering time did you spend on the self-healing solution? If you could estimate, was that 1,000 hours? Was that, and overall, I mean, looking at the solutions, products is pretty simple as far as the healing logic itself. Yes, a lot of time.
Yeah, so we are, in a way, we are a little bit of lucky people because we have to implement this solution for the product that we want to use to implement this solution. So we know these products in and out, right? So like LI query, log inside query, or vRops alerts, it's like, matter of minutes, right? But where we had to spend time is somebody needs to go and look at these failures and see, hey, when this happens, take this action. If we know that rule, putting together is very simple thing, right? Especially even for you guys, if you're VI admin, if you know the vRops and vRealize products, it's not going to be that hard. But the real thing is, what are the problems that you want to remediate? Finding that out, that's going to take some time. Any other questions? Okay, that's it. Thank you, guys.
Thank you so much.